Okay, I'm back, and now we want to calculate where the image would be located at. So in our previous segment, what we did was we used geometry to figure out where the image would be. This is the object, and then this is the image, and we said to draw a horizontal line, and then when it hits the lens, ricochet it through the focal point, and just keep on going with it. The second rule was to make a line go through the center of the lens, and then it doesn't change its direction. So it just keeps on going in a straight line, and then where those two come together, that's going to be the image. So we're going to use O for object, I for image. And I told you to get out your ruler and to measure this distance. So measure the distance from the lens to the object, and that's going to be on your here. So distance from object to the lens measured. Okay, so you're going to put that number right here. Okay, then you also have take your ruler and measure the distance from here to here. And so this is going to be the focal length, and you're going to put that up here. So you're going to have, now you could also measure it on this side if you want to, but it's the distance from the lens to the focal point. So you're going to know that one, and then you're going to calculate where the image should be, and then you're going to measure the distance to the image, and then that is going to go right here. So the only thing that we don't know yet is this box right here. Distance from the lens to the image calculated. And in order to do that, we're going to use equation 3.3a.2. So we got this equation here, which says 1 over the focal length is going to be equal to 1 over the distance to the object plus 1 over the distance to the image. Now I want to do a sample question for you, and then you're going to take the numbers that you got in here and you're going to plug them into the formula. But I just want to show you how to use the formula. Okay, so let's pretend that the distance from here to here, so my O is going to be equal to, let's say 30 centimeters. So I'm just making up numbers here. So 30 centimeters. Okay, then let's assume that the distance from the lens to the focal length, focal point, so that's the focal length. So let's say that my focal length F is going to be equal to 4 centimeters. And then the goal is to figure out I. And we'll put a question mark. So what is the distance to the image? And now we're going to take this numbers, plug it in over here. So we're going to have 1 over 4 is going to be equal to 1 over 30 plus 1 over I. So we don't know what I is yet. So 1 divided by 4, so I don't even need a calculator for that. So 1 divided by 4 is 0.25. So 0.25 is going to be equal to, okay, now I'm having a little bit of troubles here. So I'm going to go to my calculator, and I'm going to take 1 divided by, no, that's a plus. No, that's division. So 1 divided by 30. Okay, now we got 0.033 plus 1 over I. Okay, now take this over to the other side. So 0.25 minus 0.033. Okay, 0.25 minus 0.033 equals, okay, so now I've got the number 0.217 is equal to 1 over I. And every single time that I do a test, there's a student that says, yep, that's the answer. So the distance to the image is 0.217 centimeters. Now, almost there, but not quite. So I need to get the I by itself. So I multiply both sides of the equation by the letter I, and then that gets rid of this I. So now I've got I times 0.217 equals 1. So therefore I is going to be 1 over 0.217. So on my calculator, now you'll notice that I could do 1 and then divided by that number and then hit equals, and I would get my answer. So that's perfectly okay. But do you see this little button right over here? 1 over x. So if you press that, it flipped it. So it took that number, 0.217, and it flipped it for you. And so then this is equal to 4.6. And if you want to go to 3 significant figures, 4.61 centimeters. So that's how you're going to use that formula. So what you've got to do is use the numbers that you have in here and then solve it for the I and then compare it to this number down here, and they should be fairly close. So these two, the measured and the calculated, should be very close to each other. Alright, so that leaves us with our post-lab questions. So what's the purpose of the lab? What is the law of reflection? So you should know that. Now here's an application. Number 3. When would you want to use a plane mirror? Under what circumstances is a plane mirror handy? Okay, when would you want to use a concave mirror? And when would you want to use a convex mirror? So look it up on the internet if you want to. So what's the usefulness of each of these different kinds of mirrors? Excuse me. Okay, next is, what is refraction? Okay, what is the focus of a lens, or what is the focus of a mirror? Okay, here's another application. So when would you want to use a plane lens? When would you want to use a converging lens? And then when would you want to use a diverging lens? So you might want to think about microscopes, and you might want to think about telescopes and how they use lenses. You might also want to think about eyeglasses, all of that. Question number 7 is, an object is located 10 centimeters in front of a converging lens that has a focal length of 3 centimeters. I was just looking up here to make sure that I hadn't done this one for you. Calculate where the image is located. So do it. Okay, then make a drawing showing where the image would be located, and then paste it into the document. So again, go back to Microsoft Paint. It doesn't have to be exact. So if you want to just make a very crude picture and then show how you use these lines in order to figure out where the image would be at, and then paste it into the document, and then you're going to remember you're going to be emailing me a copy of the lab. So that is our lab for today. So in our next lab, we're going to be discussing what is interference, diffraction, and then polarization. And I will see you then.